This is a demonstration of exercise M532 using sensitivity analysis. My Tierra Driving School charges $680 per student to prepare and administer written and driving tests. Variable costs of $408 per student include the trainer's wages, study materials, and gasoline. Annual fixed cost of $63,920 include the training facility and fleet of cars. In the first requirement, it asks us for each of the following independent situations, calculate the contribution margin per unit and the break-even point in units by first referring to the original data provided. So in situation A, it asks us to calculate the break-even point with no change in the information. So in the problem, we are told that each student is charged $680. So that would be our net sales revenue per unit, and the variable costs are $408 per student. So subtracting the variable cost from the net sales revenue per unit, we get $272 contribution margin. Next, we're going to take our fixed costs, which were given in the problem as $63,920, and we're going to divide that by our contribution margin per unit. And since this is our break-even point, our target profit would be 0, and we see that we need to have at least 235 students in order to be able to cover our variable and our fixed cost at the break-even point. In situation B, it says decrease sales price to $544 per student. So now we're going to decrease our sales revenue per student to $544, but our variable cost per student will remain the same. So we see now that our contribution margin per unit is $136. Our fixed costs remain the same at $63,920, which when we divide by the $136 contribution margin increases the number of units or number of students we need to break even to 470. Next, the problem asks us in situation C to decrease the variable cost to $340 per student. So we're going to go back to our original sales revenue per student of $680, but now we're going to decrease the variable cost to $340 per student, and we see that the contribution margin goes up to $340 per student. If our fixed costs remain the same at $63,920 divided by the higher contribution margin per student, we decrease the number of units that we need to break even to 188. Then in the D portion, it says decrease fixed cost to $53,040. So that does not change anything about the contribution margin. We will keep the same sales price per student of $680 and variable cost of $408, so our contribution margin would be the same, $272, but now we're going to decrease our fixed cost to $53,040, which divided by the original contribution margin gives us a lower required units to break even of 195. In part 2, it says compare the impact of changes in the sales price, variable cost, and fixed cost on the contribution margin per unit and the break-even point in units. So we see that when we went to situation B, where we decreased our sales revenue, that decreased the contribution margin per unit, and with the same fixed cost, that ended up making us have a higher number of required sales in units to be able to break even. So decreasing your sales price is going to make your break-even units go up. And then in part C, where we decreased our variable cost to $340 but maintained our same sales revenue, we notice that our contribution margin per unit went up. If our fixed costs remain the same and we have a higher contribution margin, then we're going to have a lower number of units that are required to break even. So lowering your variable cost will lower the number of units you need to sell to break even. And then in the last situation, we decreased the fixed cost to $53,040. So when we're only decreasing fixed costs, that does not have any effect on our contribution margin. However, when we have lower fixed cost and we're dividing by the same contribution margin, we will see that the number of units that are required to break even will be lower. So that is the conclusion of the demonstration for exercise M532.